Hey everyone, today I'm going to be showing you how you can make an enemy AI so the enemy can actually follow you wherever you go. So you can see here I have a game open, and this is actually from my devlog series of a game that I'm working on, and you can see that this enemy spider is able to easily follow me wherever I go, and also when it reaches an obstacle it also even jumps. And so example, if you go above the spider will jump. So yeah, whenever this green line is pointing upwards, the spider will jump. And yeah, I'll exit out of this and show you a few things. So if we go over to the right here, you can see the correct script is this one right here. Yep. So you can set any target that you want for your AI. You can have a certain distance that it'll be activated from. You'll have and how often you want it to update, and all kinds of other behaviors that will make completely customizable. So when you include this in your game, you can change them however you want. Alright, let's get started. So before we can get started with our pathfinding, we need to make sure our scene is set up correctly. So you can see right here I have a simple scene set up, and what I'm doing right here is creating a polygon collider. So what this will do is allow us to have good collisions in our game. So just make sure you have a polygon collider or a tile map collider or just whatever you're using for your game. Next, what we need to do is make sure the layer is correct. So we have right here a tile map, and that's where the polygon collider is attached to. So let's go ahead and create a new layer, and let's just call this layer ground. Alright, if we go back here, then we can set it to the new layer. Okay, now I'm just setting up a player character with some basic behavior. So he'll have a capsule collider in order to collide with the environment around him. So let's just make sure this is working. In order to make sure it's working, we also need to have a rigid body, because everything we're doing here is attached to Unity's built-in physics engine that they already have. So let's see if this is starting to look alright. Yep, and you can see that we have the character and he's correctly colliding with the ground here. Okay, awesome. We can now get started with the enemy. So I'm going to rename it to enemy right here so it's obvious. And the first thing we can do is create a new layer and just create this as the enemy layer. Alright, if we go back, then we can set it to enemy. Perfect. And we can also add a collider. In this case, I'm thinking we can go for a circle collider. And I'll downsize it to something more reasonable. Yeah, something like that. Alright, it doesn't have to be exactly perfect. And then after that, what we need to do is we actually need to add a rigid body. So go down and select the rigid body 2D, and we want to, yes, have it simulated, and we also want a little bit of linear drag here. And let me see what else. Everything else will have to be adjusted based on your specific game, but we probably want to freeze the Z rotation, so that makes it so the object doesn't like turn upwards and downwards. It's always facing the correct direction, sort of. Alright, perfect. So that's all we need to do for that. And next, we can actually add we can actually add a new script in this case. And I am just going to call this the enemy AI script. You can call this whatever you'd like, however. So, yep, create and add. You can click that, and then hopefully it loads up for you. Like it's taking a while from my game, but alright, let's see here. Then we can click on edit script. And you can see here that we have just the general Unity script, which we're going to be adding a lot to now. But actually, before we add anything to this new script we just made, we actually need to go online and download the Astar project. So just so you guys know, this project that I'm showing you, or this whole tutorial series, is based on Bracky's tutorial series, so you can watch his for more information on exactly how the Astar Pathfinding project works and everything. But what you need to do is you need to download the free version, And then once you download it, you're going to need to, let's see here, import it into your project, which I can do just by dragging it in there like that, and then clicking import. Alright, and if something like this comes up, you can just click reload, that's fine, no problem. And then, yeah, if you go back here, you might have some error or warnings. Hopefully, if you have errors, you'll need to investigate that, but alright, perfect. So if you click on this, we have the whole Astar Pathfinding project, which provides us everything we could possibly need in order to get started. And what we're going to do is actually import the correct Astar game object that we need. So what we need to do is we need to go just add, create empty, and then we can just rename this to Astar, and you can see it's at 0, 0 here, and then we can actually add the Pathfinder. So what this is it allows us to create a full grid, and any object can access this grid that we'll be creating here in order to pathfind to a specific target. For example, in our case, the enemy right here is going to pathfind to the player. So what we can do is we can create a new grid graph. And yeah, let's take a look at this. So you can see here we have all kinds of values inside the editor. And, whoops, what we want to do is we want to select 2D because we're working on a 2D game here. And then you can see here's the grid again. So let's actually change this to like 100 by 100, and then we can click on the scale and actually bring that down a little bit. Okay. Actually, it's not resizing quite correctly, so let's try that again. Yeah, so what we need to do here actually is change the node size to, let's just say 0.3 as an example, and move that up. Okay. And so what this will do is this is the granularity, or how specific the pathfinding will be. So you can make this as general or specific as you want to. In our case, what I have it at right now is probably a bit too much. So let's actually try 0.5. Okay, so it was kind of erroring out before, so I just needed to readjust the values again, and you can see it's now actually working correctly. So you can see it's correctly estimating how many of these blocks are inside or outside of the mesh. And you can see here that there's a lot going on down there, and that's just because I never actually finished up moving this mesh, so let's just do that right now. Okay, not that it matters because it's off screen, but it's still nice to have it working perfectly. And then if we go back, we can actually just readjust the values again, and it'll work perfectly. I think there's a refresh section in here somewhere, but I'm not exactly sure where. But anyway, you can see that this one is kind of a problem though. It's not perfectly lining up. As you can see, the grid is just slightly outside there, which is not great. So maybe we do want to have the granularity be a little bit more. Or what we could do is we could actually move this over a little bit. So I'm going to go into here, and you can see I have the box collider. So if I just move it in a little bit, and if we, where can I adjust it? Well, I can just adjust it here. Yeah, so if I move it back to 0.5, you can see it now fits perfectly right here. And so just play around with it to get it to how you want. And next, we can actually start working on the enemy again. So I'll just save this, and I'll go back to the enemy. Next, what we're going to need to do is look at our enemy script again. And add a new script in. So this is the seeker. The seeker script is just what we're going to have to use in order to have something that we're following in our game. And that'll also give us the gizmos, which will be really nice, and I will show you later how that all works. But anyway, we added the seeker script, which is just a requirement to get this Astar algorithm sort of working correctly. And beyond that, we have everything we need. We just need to write the code at this point. So let's open up our script here. And right at the top here, we're going to have to add using pathfinding, because the actual package is different from the default Unity package. So we need to basically import that there. And I'm just going to delete all this. We're going to add it back later, but we can create a new header and call it pathfinding. So this is going to show up inside the script editor at the top there, or back in Unity. And we want to have a public transform target, public float activate distance, and we can set a default value. I'll just do 50 for now. And so, of course, this is going to be the target that the enemy is targeting. That's the activation distance. And the public float path update seconds equals 0.5. So this is how often we're going to update the Astar algorithm that we're using. And here, physics, we're going to have a speed, and let's default this to 200. And then we'll have a next waypoint distance, and we'll set that equal to 3. So that's how far away the enemy needs to be in order to start moving towards the next waypoint instead of the current one. Public float jump node height requirement equals 0.8f. So this is how vertical the next node needs to be in order for the character to actually jump. And then next what we have is the public jump modifier. So this is basically just setting how high and how powerful the jump is for the enemy. And then here we have the jump check offset. This is more of a collider thing, which you just need to adjust it to make sure it's right. And then here we have the custom behavior. So this is useful for if you want to have perhaps really dumb enemies or something. So we'll have follow enabled, and this can be defaulted to true. So if this is false, then nothing in this script is going to do anything. So perhaps, I don't know, you have your enemy die or something, so you need to disable it. And then the jump enabled if you want that. And then direction look enabled equals true. So that's to see if it'll change directions or not. And by that I mean the sprite actually. So you can see right here it looks really nice, and we can adjust all of this straight from the editor. So you can add this to a new enemy of a different variant, and then you can change all of the values to make it completely original. So yeah, perfect. Let's continue. Now we're to the private variables actually. So we want to have a path, and that's one of the pathfinding features. So we'll use the path that they provide us. And then we want the private int current waypoint, and that'll be 0. Bool is grounded equals false for the jumping, of course. And then seeker, which of course is the other script that we have in here. And then the rigid body, we'll just call that RB. So we can get started with making the start script here. And we can just find the seeker so that we can use that correctly. And then we'll also get the rigid body 2D. Perfect. And then next what we want to do is we want to do invoke repeating that quick line of code here, which is also from the Brackeys tutorial, something that I didn't really know about. But what this does is it will keep on repeating the same script over and over again based on sort of like a coroutine sort of deal. And yeah, it'll do it every single path update seconds, which is what we set up here. Because using the Astar algorithm can be quite intensive for your computer, so it's good to not have that running all the time. Next is the fixed update. So what we want to do is we want to see if the target is in distance, which is another thing that we set up there. We haven't written this function yet, but we will pretty soon here. And we want the follow to be enabled. If both of those cases are true, then we're going to follow the path. This too is something that we'll add. And then we also want to make update path. Update path. So this is another set of checks that we're going to need to do. So first of all, if the follow is enabled, and also the target is in distance, just like before, and we need to make sure that the seeker is done. So what this means is the object has been found that we're trying to seek, basically. And we want to do the start path, and we want the position of the rigid body, so the position of ourselves, basically. We need to find the target's position, and then we have on path complete. Alright, perfect. All stuff that we will add soon, don't worry. So then we have a path follow, which is what we started up again. And this is the really long script. So actually I'm going to copy it in piece by piece because it's really long. So first of all, we just need to make sure the path isn't null, and also the waypoint is not already over, like we haven't already covered all the waypoints. So then after we do that, then we can see if we are grounded, and we make a raycast, and this raycast just returns true if it is colliding with something, which means we're on the ground then. And then here we have a direction, which is just calculated, and then we want to also have a force applied. Well, right here it's just created, but we will apply it just based on the direction we need to go. And then next we want to add the jump, and sorry, I will zoom out so you can see everything here. And then for the jump, we want to make sure the jump is enabled and grounded, and if that's true, then we can add the force for our jump. After that, we will actually do the add force for the movement direction, and then we will calculate if we need to head towards our next waypoint, which could be true or false depending on how close we are to the current waypoint. And finally, we just need to do some graphics handling to see if we want to flip the sprite depending on if it's moving to the left or to the right. Alright, yeah, that should show everything perfect. So below this, we just have two more scripts to write, or two more functions to write. So first we have the private bool, target in distance. And this is another long line that I'll just copy in. So it's just returning to see if we're inside the activate distance. So that means that it's within the scope of the enemy. And then the last thing we need to do is have the on path complete. So inside here, if we don't have an error, then the path equals the P, and the current waypoint is back to 0. Alright, perfect. So that's the entire script finished. And let's actually go back and press play and see what happens. Okay, so it's not working right now. Let's figure out what's going on. Right, so the first thing we have to do is actually have the enemy have a target. Right now it has no target, so we can just drag in the current player as the target. Really nice and simple. Yeah, so you can see here that he is getting a target line for us, however he's not moving. Well, he is moving just very slowly. So that's an example of like what I was talking before, where we're going to have to actually change his values. But you can see that when I go above him, he is jumping, which is pretty awesome. Alright, let's get working on that. So let's try changing his speed to 500 and just see what that does real quick. Yeah, so you can see that's starting to look a little bit better. And actually, yeah, so if I go to the other side of him, he will turn away from me, and you can see I am colliding with him, which is pretty interesting. But you can see for the most part, by just changing a few little values, everything is working pretty close to correctly. You can see that there are still some issues with this. For example, like his jumping's a little bit weird, but that's all based on adjusting the values over here. So let's try to fix his jump modifier, for example. Let's change that to 0.1, and let's see if that is a little bit better. Yeah, so that's looking a little bit smoother. However, he should also have a little bit more gravity, perhaps. So we can have a higher jump modifier, but also a higher gravity, so he doesn't like float. Yeah, however, his speed also seems to be affected by that. So let's change that to 9,000 or 900. Okay, that doesn't affect it. Another thing I will mention is we should also change the collision detection from discrete to continuous. So sometimes the objects can actually fall inside of the tile map, which is really not good. So yeah, I've adjusted a few values here, so let's see how things start working out. We still seem to be having some problems, but he can jump at some points, and he kind of can fly, which is a problem. But yeah, it's all about just adjusting these values now. So the activate distance, remember, you want this to be really high if you want to make it so your enemy can see you from far away, but really low if you want, for example, the enemy to be right next to you, and then they notice you, and then they can start chasing you. And also remember, all of these can be changed through a script since they're public variables, so you can have a different script that can make an enemy perhaps like way more powerful, like if you get close to them. Like right when you get close to them, all of a sudden you can increase their speed and increase all of their different variables. Or you can also have it so if an enemy's on low health, you can have the jump disabled or something like that. Just different ideas for you. So there are two more important things I need to mention real quick. The first one is the collider needs to be centered at exactly 0, 0, so there needs to be no offset. Otherwise, you'll have problems with your vector here. And so you can see I made some changes to the script right here, which I'll let you copy and change for yourself, because actually the physics raycast that I had was not exactly correct, and this will give you the correct collision value. Alright, awesome, that's the end of this tutorial. So you now have an enemy that can chase the player around and even jump. Although it's not perfect, you can go ahead and start changing some of the values here and look into other physics systems to see how they do their jumps and everything like that, but this should be a good start for you.